Okay, I will open VT lab. Okay, in the Apache Hive, as I told before, you can create the tables in the form of as an internal table and an external table. Okay, there are differences. Whatever we are doing are all internal tables only. Okay, if you wanted to specifically create a table as an external table, that you can do it. Hive deals with the two types of a table structures depending on loading and the design of the schema in the Hive. Internal table is a lightly coupled in nature. In this type of the table, first we have to create the table and load the data. Okay, we call this as this one as a data on schema. This it is a tightly there is they say like it is a tightly coupled. Okay, because first it needs the table has to be created. Okay, the schema has to be created for loading the data first. Okay, by dropping this table, both schema and the data should be removed. This is the notch here. I mean, notch means understanding should be there. Okay, when the table is dropped or when the table is deleted, both the data and the schema gets a deleted, gets a removed. Okay, normally where it gets created in user Hive and warehouse. Okay, in this location, this both the data and the schema, say I loaded a table, like a table like employee data set. Okay, that I have loaded, and when I try to delete the table, both the data and the schema will be deleted. Whereas the table is created as external table, the uh, data will be present. Okay, only the schema will be deleted. Okay, data will be present means data will be loaded into the table, Hive table, and it will be there available. Okay, and it will be the schema of that, like the definition we give, no, for an employee table we give the name, id, address, phone number, type of employment, all those things will get deleted. Okay, schema gets deleted, that's what it is. That's what the main difference is. That is the reason we say it is a tightly coupled. Tightly coupled means when the data is deleted, when the table is deleted, both schema of that and the data of it is deleted. Whereas in external tables are uh, loosely coupled between the data and the schema, because schema you can delete it, but the data still resides in the warehouse. Okay, why it is used, I will tell you shortly. Okay, when to use the internal table, if all the data is available in the local file system, only Hive is used for the entire life cycle of the data. See, if you don't want that data to be present in your Hive, okay, data and the schema completely wanted to delete it, then you have the internal tables. Okay, if whatever the table which we are creating nowadays are internal tables only. Okay, and the external tables are loosely coupled in nature. Data will be available in hdfs, this is what I said. Okay, it is present in the hdfs. The table is going to create on the hdfs data. So you store your data into a hdfs and you will create a table on the data which is present in the hdfs. Like for this movies, right, Netflix movies, and also for the other data, COVID shield data, we stored this data in the HDFS, and then we created a schema based on the data, right, to load into a Hive table. Like that's when we use the external table. External table, why we use this? Say for example, somebody has loaded your Hive table, which is in the warehouse, with a large data set, huge amount of a data set, but they don't want to remove the data from the Hive table, okay, because again you have to load it and all. Loading and all will not take less time, as we are having less numbers, less quantity of a data. It is getting loaded fast, otherwise it will take time for Hive. So performance, it will be there, it will become slow. For that reason, say you wanted to remove only the schema, or somebody else wanted to redefine a schema. Okay, I have given ID and all, and somebody else wants to give it as emp ID, emp name, or something else they wanted to give. Then they can remove the schema and give a different schema for that. So data is always available in your Hive warehouse. That's when we go for the external tables. Okay, if processing data is available in the HDFS, and if it is in the local machine, no, like we use this while we are loading, we load it from the local machine, right? If that is the case, then you can go for the internal tables. Okay, internal tables, you can delete it completely. At the time of dropping the table, it drops only the schema. The data will still be available in the HDFS as before. Okay. External tables provide an option to create multiple schemas for the data stored in the HDFS instead of deleting the data every time whenever schema updates. If there is a schema updation happens, or each of the user who is trying to load the data into the HDFS, and he wants to give his own schema definition, in that case you can go for external tables. Okay, useful when files are being used outside of a Hive. Okay, it means say if I try to delete the data, I told like it will remove it the data and the schema. But if it is outside of Hive, okay, what does this line mean is, say in a Hadoop environment, it is a distributed environment, right? In the distributed, it is providing two stuffs, we told, which is HDFS for storage unit, and another one is the map reduce, which are for analysis part. Okay, execution unit that it provides. In HDFS, if you talk about this distributed architecture, it need not be like only one application like Hive will be running. It is also possible that a pig will be running parallelly. Okay, we can write pig scripts and all, or you can also configure like HBase database, and other applications like a Spark, okay, Flume, to work on with streaming data, that is continuous video streaming, audio streaming data and all. Kafka, then all you can use it. Okay, on a single distributed environment, you can have multiple applications which can access the data in the HDFS. Okay, say I put Netflix data in here. Okay, Hive can work on this Netflix data set. Pig also can work on this Netflix data set. Flume can work on this Netflix data set. Right. So you don't have to delete this complete data. Okay. That's what they're saying when the files are being outside of the Hive. Not only Hive uses this Netflix data set, also the other applications uses this data set. In that cases, you can mark this table as a external table. So accidentally you will not delete. Even if you drop the table, the data will not get removed from the HDFS. That's what they are saying here. Okay, is this clear? External and internal table. They will ask you, okay, what is an external and an internal table? If in an interview, if you say Hive, they may ask you like, when you create an external table, okay, how do you set the properties? Sorry, when you create an internal table, and how do you change it to external table? Then using the table properties we set yesterday, right? There is an option in that. I will show you parameter. Using that parameter, you can change it to external table. Okay. Is this okay, Amalan and Venkana Babu? Okay, furthermore, loading data into the Hive, it is working well with a structured data that we know it because we are going to create a table format. Okay, with the load deals with the loading fully structured data into the Hive. Fully structured data refers to the data from RDBMS, etc., with the proper rows and columns defined. Okay, so any data which are from the RDBMS, you can load into Hive. See, you can think like I told, right, on the top of an HDF Hadoop framework, you can have multiple applications. Okay, say if you are thinking of loading a data completely where you don't have to think about the structure and all, then you can go for pigs, right? Then you say, for example, you wanted to load the data of type RDBMS. And that is datas are structured and you can load them into a tabular format. In that cases, then you can have the application Hive on it. Okay, there is a data set stored. That's data set you can analyze the data use by storing it in a tabular format. Okay, tabular format. Then you can go for not tabular format. Then you can go for Hive. Okay, if it is a streaming data and all is coming into picture, that type of data set is present, and then you can go for other applications. Okay, that's how you will design it. Okay, all application you can configure. You remember we configured pig first. Pig you can write still scripts, right? And now we have configured Hive. We can write scripts on that. We can configure Cassandra, HBase, on all those stuffs. Okay, and by default Hive uses the slash t tab, this is okay, as a delimiter. Okay, what they're saying is you have a data set with an ID, name, age and all, so the space between this data set is a tab space, the delimiter. Okay, it will you also store the data using the you store the data into the table using the tab space only. Okay, structured data can be loaded from the text files or from the CSV files, because those will have a structured data in that. Okay, this text file loading, CSV file loading we have seen. We can also load data like XML files and JSON files. Okay, there is some functions or some methods which are functions which are available in a Hive. Using that, you can load the JSON data. JSON data means it is a JavaScript object notation data. Okay, it will open and close with a curly braces, and it will have values, name and the value, like a map. It will be having it. Okay, this data you can load. Many names and values will be there. This data also, this type of data also, data set also, you can load into Hive and you can work. Okay, this is a semi structured data, XML, and XML will have tags. Okay, like XML, and it will have that XML files we have seen, no configuration files. These are all semi structured likewise, because many tags you can have. It is not uniformly that between every XML tags there are only two things. Okay, there can be many tags inside, that's why it is semi structured. Okay, can be processed with less complexity using Hive. First we will see how we can use Hive for XML. Okay, there is something like XPath method. Using that, you can load the data, XML data into your will be able to fetch the data stored into the XML tags. Okay, using this XPath, you can fetch the data which are stored in the tags. That's what they are saying it. Okay, Hive working with a complex data type. So till now it is clear. What we are seeing here is like how the tables of the Hive can be created, like an external table and an internal table, and how the data, what kind of a data Hive can work on, structured and semi-structured data. Semi-structured data like JSON and XML also can be loaded into your Hive table, and you can write processing. Why, you can ask me, you have not done any processing is all nothing but you are going to select some values based, or find the average, and find the minimum maximum salaries. All those are the processing. Okay, those things which we have already seen in MySQL itself is processing only. Okay, and furthermore, so other type of data sets, we have seen the data types like integers. It can take a strings, it can take a varchar, right, and character type and all. So other complex types like how we can load our data set is if we are containing values in the form of arrays, okay, that you can load it in the form of arrays means say some integer value is present and it is having values from 1 0 1 2 3 4 5. Okay, so this you can say you can give it like values are from 0 to 5. Okay, this you can load it in a form in the array, right? Likewise you can load the data and map key in the form of a key value pairs. Key value pairs means like a person where he is belonging to Chennai. Okay, another person is belonging to Delhi. Okay, what the person is a key and the value for each person is changing it. Likewise also you can load your data, I will show you. And the structure format is of different types. Okay, like in C programming languages and all, structure open braces and close braces, like it is containing heterogeneous type of data. Like integer data it is containing, and the city which is a string data it is containing. All those things are which are present, then we call it as a structured data. Say good example you can think of for structure is address. Okay, for an address you can say like a street name, street number, name, and name of the street, and what else, road and avenue. Okay, these are all can be string, this can be integer, and pin code, sorry, city, state, country, and pin code. Okay, our country code, all these things are, this also contains string and heterogeneous I mean and integers also, no. So all these things we can group it together as a heterogeneous data. We'll see the examples in this. Okay, array they are saying like if you consider a kind of a box. Okay, this is the box, three-dimensional box. It is they're saying like, see if you are having a box. Okay, some boxes are delivered to you, and that data set is having number of the box and medium sizes of the box is also there. Small size, medium, and a big box, and the size is given in a dimension. Okay, like a length, mm, width, length, height, and a width, right? L into height into width. Okay, this three-dimensional box is given all these things. Okay, the size of the box, then you can put this into an array. Okay, like array length, okay, and height and w width for each of the boxes, for the small box, for the medium box, and for the big boxes. Okay, guys. So this you can think it. Then how do we load if a data set is of this type where we can identify particular parameters in arrays? Then you have to create a table. Okay, to load this data. Say this data you got it and you wanted to load this data into a table. Then you will create a table. Okay, namely the parcel box, and it is having ID, box name, and box name as a string, and the dimension they are giving in the form of array. Okay, so dimension small box will have a dimension 2 2 2, medium box will have a dimension 5 5 5, and big box will have a dimension length, height, breadth, length, breadth, and height, I think, right, I'm saying it wrong, length, breadth, and height. Then that will 12 12 12, that you can put it in an array. Okay, you have to write it like this: array of what type? It is integer type. Arrays will hold only similar type data type elements, right? So it is of integer type that we are giving, or arrays of string types can also be there. Okay, and rows format delimited, fields terminated by comma. How we are going to load your data in table, that you are giving it here. And the collections, since this arrays, maps, and the structures are all collection of data inputs, right? That's why they have this collection keyword. Collections items terminated by dollar. We have to mention how this is terminated. Okay, that we have to mention it dollar. Okay, guys, we'll see an example, then it is fine. So if you wanted to access only a particular length or a if say when we put any elements into an array, then how we going to like array 1, 2, 0, 1, 2, then how are we going to access that array elements using the index position, right? That is why if you're going to select and find a particular mm, parcel box number like a dimension, then dimension of a 0 from the parcel box, where cost, this is the cost field, you can see where cost is less than 50, likewise you can retrieve it. We'll see example in this, no problem. Likewise a map, if a map is there, then the same thing you can say it as a map like a string comma 1, like a length. Okay, here if string they are giving it as x, y, and z as a dimension. So x comma 2, y comma or y comma 2, z comma 2. Okay, length, breadth, and height. They are giving it with the parameter x, y. So it is a key value pair. For x, for the small box, it is having 2. For y, for the small box, it is having 2. And for the small box z, it is having 2. Okay, so maps is like key value pairs. If you are seeing anywhere, then you can load your that type of data into your data set as map. What you will mention while creating the table, you will mention it as a map. This is the name of the field name we will give, and map inside it what type of value is going to be the key, and what type of value is going to be your uh, value that we will give it. Okay, in order to access the map, you can either pass a single that key, okay, in the name, and this is the name of the field, and the particular key if you pass, then you can retrieve that particular data. And the structure is same, but you have to mention this. One more thing again, in map you have to mention like map keys, how they are terminated, because here if you see, this whole thing is one key value, right? And it is delimited by dollar. The another key value pair is this one, the third key value pair is this one. It is delimited by dollar. Key and value or itself is delimited by the hash, that also we have to mention. Okay, while we are creating a table to load the map kind of a data. Okay, and in struct, it is a heterogeneous type of a data. Okay, so it is a, like it can have an integer, or it can have a string, it can have a date format. Okay, or float. Likewise, if it is there, then you will mention during the creation of the table structure, okay, name of the field, and what type it is. Okay, likewise you will mention it. Here it is all integer they have mentioned. Otherwise, it can take heterogeneous data also. So if you wanted to access a particular element like weight, okay, weight is the second field. Length, weight, and cost, they are merged together. So weight, if you wanted to access, then you will give the name of the structure and which field you are going to access, okay, with the where condition. Okay, what we are seeing here is about the complex data sets. If in cases your data set looks like it contains array of elements, or if it contains a key value pair of elements, or if it contains multiple elements like address, you can think here. Okay, address, in that you can have like number, street number, which can be integer, street name, which can be uh, string. So heterogeneous data type of information, if you see it, that if you can put it in a structure, then you will use the struct data type. Okay, struct format. Okay, this is all about this. Is this okay? Am I going fast, or is it understandable? We'll try to create internal and external tables, see the differences, and we will load one JSON file, and we'll see arrays, maps, and structs. Is this okay, Amalan and Venkana Babu? Any doubts? Doubts you are having? Any question? Okay, fine. Now we will see some demos. Okay, we will go to ours. Before that, is there any movie data set? I will check. Okay, there is nothing movie. Okay, okay, hope you can see my screen. Okay, we'll do that. What happened? Okay, I will enlarge this. This has this movie data. So this is another mission. Okay, this is having that movie data sets and all. So I can use it. Okay, say I take this a movie, take movies a dot text file. Okay, it is containing some information about the movie ID or something, and the name of the movie, year when it is published, rate of the movie, and number of viewers of the movie. Okay, number of viewers of this movie. So this data set we will load it. Okay, we can and see what it is happening between the internal table and the external table. So for that reason, I have to come out of this. It is not working. Okay, so I have to go to Hive prompt, but it will not come, I think. Let's see. Yes, it is not coming here. Okay, 1 minute. I'll take those data sets so that we can work in that rather than typing it again. We cannot type it because it is a large. So I'll just take that. Okay, it is copied. So I go to home location. Okay, then there is a Hive commands. PWD, where did I download? Okay, it is in the downloads directory. ls-lrt. I have a Hive commands. Okay, in this I have a file. Hive commands ls-lrt. We have this movie text.txt. So this file we will load it and we will work on it in the internal and external tables. What I will do, so first we have to create a table for this, right? Create this file is present locally. So create a table. This is an internal table, but here I cannot do it. I have to go to Hive prompt. Okay, it's not coming. I'm launching Hive now. Okay, in the Hive, I will create a table. Create a table, and the table name I will give it as a movies. And it was having all these things, so like a movie ID as an integer I will give, and movie name, movie underscore name as a string I will give, and release year as int I will give. Okay, row format, we are going to see how we wanted this file table. Row format delimited fields will be terminated by comma. Okay, so enter this. It is throwing error. I think some error I have made mistake. Terminated by bu have given by. Okay, enter. Hive session metastore client, some problem is there. It is working, right? Some metastore problem it is showing. I think I should start the schema tool again, but you should not do it. Here it is giving some metastore problem for me. So I will run the schema tool again. Schema tool hyphen db type which we are going to use is a derby and init schema. Okay. So again I will launch Hive. So this will not have the old commands. Now we cannot. Yeah, it is there. Then I'll create the table. Let's see what it is happening. Yes, it is fine. Some problem with the schema. Metastore it was throwing for me. So I have recreated the metastore. Okay. So the table is created. Okay, this will have an entry. Actually, I'm not using any database. That is the reason it is throwing error, I think. Right, we have to use the database, right? Now it is using default databases only. Show databases, I think the old one got deleted because I init schema I've given. So default only is there. In this movies table is created. Okay, we will load the data into that load data. It is present in local. Okay, so I will load it from local only. Local in path and the location is home and islet. I think documents downloads it is there. I'll take that path. Yeah, in downloads Hive commands. Okay, pwd, this is the path. Downloads Hive commands. Okay, in this we have movies or movie, I don't remember. Movies.txt. This file we are going to load into the table movies.txt into table movies. Okay, enter into the table. Which one? We have created the table no movies. Into that we are going to load the data set. Enter it. Okay, it is loaded. Okay, I'll describe and check about the table. Table is movies. Okay, it is all having this MID, movie number and release date, release year. Then I will select star from movies table. So it is giving only the ID, name and the year. That's what release year I have taken. Okay, say for example, we will check whether it is created in the HDFS. In your warehouse, Hadoop fs -ls /user /hive /warehouse. Okay, it will be in the default database. Okay, movies is created defaultly in the warehouse only. It gets created, it is present here. Then we can also check whether it is loaded properly. Go to the movies. In this movies.txt we can check it. Okay, cat that file and check it. Cat and movies dot txt. Okay, it is loaded properly into the table. Now if I try to delete the table, okay, movies table, drop table name. This is how you drop your table movies. Okay, it is done. Now we will check it in our HDFS. Okay, ls whether it is movies table is present. In the warehouse we have to check. Okay, cat I have given, it should be ls. Ls will list it. Okay, see that a table is completely removed. That movies table. Okay, whereas if you check the schema, describe the table and check the schema, describe movies table. Schema is does not table not found movies. Okay, so if you understand, no, when it is an internal table means if you don't have it as a externally, if you delete the table, both the schema and the data gets removed, even from HDFS warehouse or from anywhere. Okay, in from the HDFS warehouse it gets deleted. So this is fine. I will create an external table and show now. Okay, now how do we create an external table? Same for the same movies.txt dataset. We create an external table which is create table. You have to use create external table. Okay, so you have to use the keyword external table, and I will give the name as a movies underscore ex, and I'll say MID. Okay, movie ID int, same like that. Name as some string and rel year as int. Okay, same thing like a row format delimited fields terminated by colon. Sorry, with a comma. Fields terminated by comma. Okay, so how to create an external table? Create external table keyword you have to write name of the table, and then whatever we have to give, it is the same. It is created. You can check the schema for this table movies underscore ex. This is a my name. This is the name of my external table. Okay, all these things are there. Then it is present in the HDFS because in the warehouse it gets created. No, so if you check if it is present in the HDFS, yes, it is created. Movies.exe is created. So how do we check it whether the data is deleted or not? Then what I will do, I will drop the external table. Okay, drop a table. Table name is movies underscore ex. Okay, it is a dropped now. When I check the data part whether it is present in where user Hive warehouse, then I will list it. Okay, fs list user Hive warehouse, enter it. See movies.exe is present, it didn't get deleted. But when I check the schema, okay, this I will font one level, I will increase it. Now if I check the schema for describe the movies table, movies underscore exe, it will say schema does not present. Okay, what does it mean? The data is always present in the table, will always be present. The table other users can also create a schema for that and use the table completely. They can go and read the table and they can create their own schemas. Okay, that is what the external table advantage is. Okay, they can have their own versions. Is this okay? Okay, this is about external and internal tables. Then we can also load the table in the form of a JSON, I told, right? So we just go to our Kaggle, okay? There we will try to download. Here I have already logged in. So what I will do, in the Kaggle, I will try to download. There is some iris data set. Iris is a flower, okay, from Ireland, I think Ireland or Italy, I don't know. There is an iris data set, some species data set flower that was containing a uh, iris flower dataset containing JSON files kind of data. Okay, this is about the dataset. It is a flower set. Okay, is introduced by the British statistics. He wanted to do some analysis for this flower. Okay, how it is. based on its petal length. He's taking this attributes like petal length, petal width, sepal width, class, species, which species it belongs to. Based on that, he wanted to do analysis, collected the data of quantity for data to quantify the morphological variation of the iris flower of three related species. Okay, 50 samples he has collected, and he is doing some analysis on this. He wanted to check the measurement of length and width of the sepals and petals. Petals, you understand, no, that flower petals will be there in centimeters. He wants sepals, I'm not sure. Okay, he wanted to do some analysis on this data set, and this data set, I will download this. I have already downloaded it, but anyway, it is coming as archive. Okay, I'll show you how that file is there because I have that already. Okay, here it will be there. Mm, okay, there is iris.json file is there. No, it will look, that's a file. Okay, so this is how the file is. If I open it in a notepad or something, Hive commands, iris, JSON. Okay, you can see it here how it is looking like. It's not getting enlarged. Can you see it is starting with the open braces, open square brackets, and it ends with the open square brackets, and it is containing many open and closed square brackets. It is containing about three length about the sepal width and petal length width and the species which it belongs to. This information it contains. Okay, this is a JSON file, they say it. So if you can see it here also. Okay, it starts with this, and inside it, each one is like in our Java programming, Java classes we write no open and closed braces. Likewise, it is all written. Okay, value for each. Okay, this a file, how, if it is a JSON format file, how we can load it into Hive, that we see. We can call this a semi structure. Why? Because see, it need not be all the time like three fields we are having it. See here we are having sepal length, width, petal length, width, and species. Five fields are having. It need not be five fields alone. It may be like six fields you can have, and that at that time it will, you cannot load that data into a row and column and all. No, so this is a kind of a semi structure. Okay, semi structure means half you can get it proper format, other half maybe different format, or it is a mixed. Likewise, that's why we say it as a semi structured data. So now we will see how to load this data. Okay, so for that, what we have to do is we have to go to, you have to create a table to load the iris data. Okay, I will pick that. Okay, so what we have to do is, I'll create a table. A table can be created saying create a table, and the flower name I give iris flower. Okay, and directly you can load the complete data set. Okay, say flower name as a string. It means the whole data set is there, no? This iris JSON file, whole thing as a text file, I am loading it. Okay, you can think like loading into a flower name or flower. Flower I can give into a type. Okay, into one type, one column, flower, and the type of that column I'm saying it as a string. Okay, irrespective of it is divided in rows and column format. Sorry, key and value pair also you can think right here. Sepal length 6.4, sepal length 6.0, key and value pair also you can think. So but as a whole, this since it is a JSON file, as a whole I can load it into a table. First I create a table like this, then I will load it into the table like a load uh, data local in path. Okay, that file name where it is present locally I'm going to give. Okay, where I'll take the location. It is here, iris.json file slash iris.json file. Okay, uh, In path, this is enough. This will itself load it. Okay, into table we have to mention, right? Into table, which table we wanted to load? Iris table. Okay, first I created a table for the whole data set, and I'm going to load the data into Iris table. Okay, JSON data. It is done. It is loaded into default database Iris. Okay, then we can check it in your HDFS, so how it is loaded. HDFS in the warehouse, it will be there. It will be there in our outside only. Well, first I'll show. Say Iris data table is created. It is created as a directory. So if you wanted to check inside the directory, okay, JSON file is there that you can view it. It's a directory to say, okay, dot JSON I have to give. Iris file name I have to give, no, to view the content of the file. Okay, it is a loaded. See how it is a loaded in your uh, Hive data set as such. Okay, open and close. Okay, after loading it, say we loaded it. What we why we are go loading the data? We wanted to analyze it, right? Say if you wanted to get a particular species value, or if particular length, petal length, or any species, then you can use this select. Through select query you can get. There is a method like a JSON, get JSON object. Okay, with that you can give the name of the field, which is a flower, and comma, and which field you wanted to access. You can give it as dollar dot species. Okay, if you see it here, it is having species field, right? That field I'm going to access it. Okay, that I am giving it in quotes. So this is how you can access a particular element in JSON. Okay, select get JSON object. The JSON object is going to be my species, which is present in the field. Field is flower, because we have given only one field, right? One attribute, one column name, flower, and which parameter we are going to access, that is species. That you have to give it with dollar dot species. Then enter it. Invalid table aliases flower. It is saying like that. Species is right. SPECIES. Flower is the column name. It is correct only. Why it is throwing error? Can you see any error in this? Flower is the field name which I have given, and the species is the value. This is how we have to do. Suspicious. Invalid table name. Alias or column name flower. I will again do that. Maybe some other name I give. Let's see. Okay, I create a table with some other name. It is already existing, it is saying. So I'll give the table name also different. Then I will load that table into iris1. Okay. After that, I will do select flower underscore name, comma, or this I should not give correct one latest. Dollar dot species. Okay, I have to give the from where we have to get it right. Table name I have to give. Right, that I am not given. That's the reason it is giving error. How it will know where to get it? Okay. Table name I am not given. This aliases also you can give. Same like in our MySQL we see no aliases. Some meaningful name we give no like that. See it is taking the species of all the species from the data set. I have not given the table name from where we have to give no select star select from. So in the star you can give the JSON type. Okay, JSON type of the field. Field is a flower and the which field you wanted to access it. Then it gives the result. Okay, it is having species like Virginica, versicolor. Three species he was access dealing with. Sentosa, something like that. Okay, so this is fine. So I have given for one species, right? One field to access it, one element. Say for example, if you wanted to access more elements, then you can give a comma again get underscore JSON underscore object. In that you can say the flower is a field, and say we wanted to find the what all is there in this, like say sepal width. Okay, we also want to find the sepal width. Uh, and dollar dot sepal width. What is the sepal width? Yeah, the sepal width field value only you wanted to find it for all the species. Okay, that also is possible from iris. Enter it, then it gives for all the species with the value. If it is not there, it is giving null. For all the species, the sepal length it is giving it. Okay, or you can also have likewise you can write your queries and get the results. Fine. I'll try this. Sepal length is lesser than or greater than 2.0. Say null, no value it is giving. It is having values of about 2.0. I try to give more than 2.0, but it is replaced with null. Okay, is this fine? This is how you load a JSON file. XML file through a path we can do it, but it was giving error when I tried it. I'll check it and I will show you that also. Okay. Okay. What else is there in this? And okay, loading the data. This is fine. Okay, one thing I will show, like a load, how do we load a data set which if it is containing array formats, map formats and structure formats. We will work on more in that with tomorrow. Okay, and mostly tomorrow we can finish it tomorrow or day after tomorrow. We can finish this. Okay, now I will take something, some values like ls. We can see that there is something like array.txt. Okay, what I am writing is about some movies. I say this, I have typed it. Okay, I say like one devil adventure animation thriller. Okay, so I'm saying the movie id, name of the movie, whether the movie is an adventure type it is, the movie is an adventure movie and also an animation movie and a thriller movie, and the other movie is a chocolate factory and it is an adventure movie and a thriller movie. Okay, these things, these are delimited. You can think that this data set is delimited with the type of the movie with a colon. Okay, these things we can put it into an array. Okay, we can create a table. Imagine that this is your data set, a very small data set with only two entries, and it is containing some records or some field values which you can put it into an array. Okay, for that you have to create a table with an array, and into that array this will get loaded. Okay, I will show you how to do that. Okay, so first we have to create a table. No, whatever the data set we have to work, we have to create a table. Create, not here in the Hive. Control L. Something has happened. Okay, in this I will create a table for that data set. Create a table. I will say the table name as MOV. Okay, and in that it is having ID as an integer and name of the movie as a string I will give. Okay, and it is having other three parameters. No, like type of the movie. So type of the movie, I will say it is an array. You're going to put it into an array which is of type string. Okay, if you see in this in the small data set, this is the type of the movie and it is containing three elements. Okay, and it is of type string. Okay, that I have to mention it here. Okay, that's all. I will close this. I will create a table likewise. uh, no, I have also have to say like what is the collection type in this. Okay, for that delimited, this you can ignore it also, but collection type you have to mention. Because collection, in the collection item you will say how this is separated, what is the delimiter for each of the array elements. Okay, array elements, adventure, animation and thriller, what are the delimited elements, that you have to specify it. Okay, delimited fields terminated by. Okay, fields, we can have it like a terminate, fields are in the data set, it are all are terminated by this. And the collection items. Okay, collection items terminated by dollar. Not dollar, here it is a colon. If you can see it, the collection items are terminated by the colon. The collection, if you here what we are mentioning is it is the array. Okay, this we have created a table move, and into that table we will load the dataset. We'll describe and see how this move schema is created. Okay, you can see that array type of movie type is an array, and it is going to take the data type as array with strings. Okay, then we have to load this data. Load data, it is present locally, local in path, where it is present I have to put that. Okay, pwd, it is in Hive commands. It is in Hive commands and the text file is array.txt. Okay, and into table, which table we are going to load it? Move. Okay, into move table, parameter move is into table, right? Like this only we have to write into table. Correct. Yes, into table move we have to give. Okay, we are loading the table that array.txt, which was containing the two data set, two information about the movies that I have loaded it. Okay, so in the HDFS it would have been loaded. Okay, now you can check it in HDFS also. ls in the warehouse, it is loaded. This mov is the new table which I have created, which is present in the warehouse. Okay, now we have loaded and all. Now how do we have to say, for example, I wanted to select only a particular item from the type. Okay, viar dot text. If I wanted to find the uh, first and second value from the arrays. Okay, second value from the array of this data set, then how do we select it? Then we can give select the array name. Okay, what is the array name? Array name is type of arrays will start with index position 0, right? So second element is index position 1. Okay, from which table? Mov table. Okay, then enter, then it will give the result. See, what is the elements in array? uh, Second elements are animation and children. If you can see it in the data set, it is animation. This has only two elements, okay, and children. Okay, if I try to locate the second element from both the movies, then it is giving null for the second one. Why? Because it is not having value in the third, that is the 0 1 second index position. There is no value for the second movie, chocolate movie. Okay, we can also apply where conditions in this. Okay, where movie, uh, where the field of the movie name equal to name of the movie, I've given name equal to devil. Okay, so for that only it will give the, sorry, something has happened. For that only it will give the result. Okay, second elements of in the array for the movie devil is thriller, that it is giving. Okay, I will stop it here. Okay, we will see it tomorrow fresh about the structures and maps and some other things like partitions and the buckets. That is all in, and user defined functions will be there, that we will check it tomorrow. Okay, or shall I continue? You tell me. If I continue, I will talk about map and structures, those two stuffs. We'll see it tomorrow.